One of the ways that we use prisms clinically is for the correction of tropias. And tropia being the condition when we have one eye that's pointed straight ahead and the other eye is not. So we could have the eye deviated upward is a hypertropia, the eye deviated downward is a hypotropia, the eye deviated inward is an esotropia, and the eye deviated outward we would call an exotropia. And we also generally will describe which eye is deviated, so this would be a left exotropia. And you can see how this would cause a problem for a patient. If you think of them, I'm going to put two eyeballs here, and one is pointed straight ahead and the other is deviated outwards, so another, again, a left exotropia. If this patient was looking at a distant object here, so a tree off in the distance, according to the right eye, the tree is straight ahead. But according to the left eye, something over here is straight ahead, and the tree appears to be off at some other angle. So what happens is each eye sees a different image, and the brain has a hard time combining these images, and the person would see double. And what we can do with prisms is bend the light that is coming from this tree so that it appears to be coming from the straight ahead direction for that eye. So now there would be an image of a tree over here, and both eyes would perceive a tree straight in front of them, and the brain would be able to combine those images and see single. The thing to remember when we're talking about prism correction is that a prism will cause light to be deviated toward its base. And if the light is deviated toward the base, then it appears to be coming from a location that is closer to the apex. So if we had an object at this location, an image would be formed at this location. And remember that the goal for a functional prism correction is to make the image appear as if it is straight ahead for that eye. So if we have, for example, a hypotropia, the eye is deviated downward. We want to make an object that is straight ahead appear to be coming from this direction so that the eye will perceive it as being straight ahead. So in this case, a base-up prism would take the light from this object and bend it so that it appears to be coming from this direction. I'm going to draw a little better here. So, like this. So the light appears to be coming from over here, and the object appears to be straight ahead for that downward deviated eye. If we have a hypertropia, the eye is deviated upward, and we could use a base down prism so that light that comes from this object is bent in such a way that it appears to be coming from straight ahead from the eye up here. So a base down prism would correct a hypertropia. For an esotropia, a base out prism would be used, and this would make an object that is straight ahead appear to be coming from this direction so that it appears to be straight ahead to the deviated eye. So an esotropia would use base out prism for correction, and an exotrope, if we were to put a base-in prism, now an object that is straight ahead would appear to be coming from a location over here, and so it would appear straight ahead to the outward deviated eye. This situation here, the exodeviation using a base-in prism for correction, is probably the most common clinical scenario that you'll encounter. And if you can remember that base-in is used to correct exodeviations, you can use that information when you look at any other deviations. You know that if the eye is turned out, the base has to be in. So if the eye is turned in, the base must be out. If the eye is turned up, then the base must be down. And if the eye is turned down, then the base must be up. Now, all of these are referring to functional prism correction, meaning that we want both eyes to see the same image, so that the brain perceives a single image instead of double vision. And in order to do that, we bend the light so that the object appears to be coming from straight ahead to the deviated eye. If we were to turn the prism in the opposite direction, we could conceivably use this for somewhat of a cosmetic correction for the patient with atropia. So to an outside observer, the light coming from this eye, the eye being the object in this case, the light will be bent toward the base, and the eye will appear to be deviated toward the apex. So if the patient was wearing these prism glasses and somebody else was looking at his eyes, they would theoretically appear less deviated. But this use for the prism in tropias you're going to come across much less often.